Hello, this is the second video for the circles chapter, and here we look at the intersections of circles and straight lines. So, looking at these three diagrams, it should be clear that when lines and circles come together, one of three things can happen. It can either be the lines cutting through the circle, in which case there'll be two intersections between them. The line could be a tangent to the circle, in which case there's only one contact point. Or the line could be missing the circle entirely, so there are no intersections at all. So, when we're looking for intersections of two lines, what we're basically doing is solving simultaneous equations. So it brings in some of the skills we did there. The circle always has an x squared and a y squared in it, so this will lead to a quadratic, and the straight line will be a linear equation, so it's a quadratic simultaneous equation. And if we're concerned about how many times these things are intersecting, we're looking at the roots of those equations. So that brings in the discriminant, which we did during the quadratics. So a few of the things we've done so far this year all coming together at this point. So here we've got a straight line that we're being told it meets the circle at points, so we may be looking for more than one. We want to find the coordinates of those points. So basically that's a simultaneous equation. When are these two things occurring simultaneously? So we solve them as a pair of simultaneous equations. And for quadratic ones, we do that usually by substituting one equation into the other one. Now, usually the simpler one into the more complicated one. But here we've got an expression for y, so I can substitute that into the y in the circle equation. So that would be our first step. Make this substitution into here, so we're still going to have the x squared plus then the bracket, and then y is going to become x plus 5. So here I'm going to get x plus 5 take 2. So just to skip a step and simplify that straight away to x plus 3. So that x plus 5 is going in there, and we're subtracting 2 off it. And it's still squared, and that equals 29. So we're going to need to expand this, make it equal to 0, and then we'll be able to solve that to find these x coordinates where these two things coincide, i.e. where they intersect. So that's all we need to do now. Expand. Simplify, bring the 29 over. So we've got 2x squared plus 6x, take away 20, equals 0. And we could divide by 2 or factorise it out, either way, to get us a simpler quadratic to factorise. So in the brackets we get x plus 5 and x take 2. So two solutions, x equals minus 5 and x equals 2. So we weren't just asked for the x coordinates though, so we could just be asked for the x coordinates, in which case we'd be finished, but we want the actual coordinates. So now we substitute the x's back into one of the equations. The simpler one would be the one to choose. So substituting minus 5 into here, minus 5 add 5, y equals 0, and substituting 2 into the 2 add 5 is 7. Or our intersections. Are minus 5, 0, and 2, 7. So we were asked for coordinates, so we would not leave it as this. That's just the x coordinate, the y coordinate. These are the actual coordinates of the intersections. Example 2. let's show that this straight line does not meet the circle with this equation. So here we're showing that there are no solutions to this pair of simultaneous equations. So we go about it the same way. We're still going to have to substitute it in to get a single quadratic equation, but then we want to show that there are no solutions to that, i.e. there are no roots to that quadratic. So remember, if you were talking about roots and the number of roots an equation has, we should be using the discriminant to show whether you've got 2, 1 or 0. So we start with the substitution again. Substitute the simpler one into the more difficult one, the more complicated one. We've still got the x plus 2, that's not going to change. And then the y, the single y, is going to become x minus 7. We can now expand these two. Making sure you do the right thing with the negative. And subtract to 33. At that point. So simplifying that, we have 2x squared, 4x take 14x, minus 10x, and 4, add 49 is 53, take off the 33. Again, we can make that a little bit easier by just taking a 2 out, or just divide the whole thing by 2 if you prefer. Now, I don't want to go ahead and try and solve this, because these do not meet. There should be no solution, so I should fail to solve it if I tried. But rather than going ahead and solving, I want to use the discriminant now to show that these have no solutions. If this has no solution, then the simultaneous equation has no solution, so there is no intersection between the two lines. So b squared minus 4ac is our discriminant. Just using what's in the bracket, I don't need to use this 2, just this quadratic within the bracket. B squared is 25, 4 times 1 times 10 is 40, so 25 take 40 is negative 15. This is less than 0, therefore there are no roots. Therefore, there are no intersections between the line and the circle. So we've shown it. Okay, so if we're trying to show how many solutions there are, how many intersections there are, we use the discriminant. We're trying to show that there's no intersections. We want to find that it's negative. If we want to show that there's one intersection, i.e. to show that it's a tangent, we'd be expecting this to be equal to 0. And if we want to show that there are two intersections, we'd be expecting this to be positive. Okay, final example on these intersections. We've got a straight line with equation y equals kx. It is intersecting this circle at two distinct points. Show this. So that this is true for k. So straight away, as we see this, that should bring to mind what we did about the discriminant. That for something to have two distinct roots, we're looking for the discriminant to be greater than 0. So we're looking to bring this into the question at some point. We start, like all the previous ones, in trying to solve these simultaneously, substituting this one into this one, so that we have one single equation that represents the intersecting points of the circle and the line. So we have x squared minus 10x. Those parts don't change. Where we've got y, it needs to change into kx. Make sure that goes into a bracket when you're substituting in an expression into a single term that's squared. Make sure you don't just put the squared on the end, so it looks like it's only the x squared. Make sure you put the whole thing in a bracket. And it's 12 lots of y, so 12 lots of kx plus the 57 equals 0. Simplifying that, we can bring the x squared bits together. So this is x squared plus k squared x squared, or in other words, we factorize the x squared out. That's my coefficient of x squared now. Same thing here, from the x's, we're going to factorize an x out of these two things. So what I'm left with inside is 10 plus 12k. So that's my coefficient of x, so it's a plus because I took this negative out of this bracket. So I need to make sure I've got a negative 10, which I have, and a negative 12, which I have. And then plus the 57 equals 0. I now have a quadratic equation in x with coefficients in terms of k. So I can now look back to this. Oops. I want this quadratic, which is about the intersections, on this to have two solutions. So I need to use a discriminant to show that. I need to show that this is true for this quadratic. So I'm substituting this A, B, and C into the discriminant. And we should get something of this form. So b squared, this thing squared. Let's just write down what we're doing. We're using the discriminant. B squared minus 4ac. That's b squared minus 4 lots of 57 is 4ac. Yeah, we know that this has two distinct solutions, so we can set this to be greater than 0. We are given that fact. So it's just a case of expanding this and simplifying what we've got. So we have 100 plus 240k plus 144k squared from that first bracket squared. And then from this, we're going to get minus 228 from the 4 times 57 times 1 minus 228k squared from the 4 times 57 times k squared. And we still know that's greater than 0. Just simplifying that before we do anything else, we end up with negative 84k squared plus 240k minus 128 is greater than 0. So we can take that to the other side so that we have a positive k squared and divide by 4. We're dividing everything by 4 and moving it all to the other side. 21k squared. Take away 60k plus 32 is less than 0 because I've taken it to the other side, it's swapped around, and that is exactly what we were trying to show. Part B, determine the range of possible values for k. That just means solve this. Solve this quadratic inequality and say what k can be, what values k can be to keep this thing less than 0. So we solve solve this quadratic, so you can just use your calculator, the mode in your calculator, and put the three numbers in, 21 minus 60 and 32. Or you could use the formula, you could complete the square if you really like, although I wouldn't myself. Just using the calculator. Calculator would give us k is equal to 30 plus and minus 2 root 57 over 21. So those are our two solutions for k. Now remember, for a quadratic inequality, consider the quadratic graph. No idea what exactly this looks like, and it doesn't matter. I'm just saying, trying to test what sort of inequality answer I'm aiming for. Am I after k is less than something and k is bigger than something for these two outside bits? Or am I after k being between two things? And remember, the graph tells us which of those we wish. And it's determined by whether this quadratic we started with is less than 0 or greater than 0. So because this one's less than 0, it's this part of the graph we are interested in. So we're interested when it is between the two solutions that we found. So between 30 plus this and 30 minus this. So 30 minus 2 root 57 over 21 is less than k, which is less than 30 plus 2 root 57 over 21. It's not the nicest answer. We could get it as a decimal. We're not actually told what form to leave it in. This is exact. We could get decimals and round to 3 significant figures as well. So that's all about intersecting lines and circles. We use simultaneous equations to find any intersections. We use the discriminant to show how many intersections there may be, whether there's 2, 1, or 0. 1 would make it a tangent. And then because we're using discriminant, we may need to use our knowledge about inequalities and to find possible values or missing variables within the equations. So that's the end of that bit. You should now be able to attempt the questions in exercise 6D, so make sure you try those. And then when you're ready to move on, find the next video.